Hello and welcome to the sixth and final section of our backend volume in our full stack Kotlin application course. In this section we will be looking at communication patterns with external services. We'll be choosing a REST client to use in our application and then configure dependencies to contact our external APIs. After that, we'll be creating asynchronous calls to external services and see how we can map those call results into our objects. And finally, we'll populate the database based on the results that we get from there. In this video, we'll be choosing and setting up a RESTful client. We'll take a small look at considerations to take into account when choosing a client, and then set up dependencies to retrieve data. And finally, we'll configure a REST client and set up the initial paths that we will be using. If we think about our application, we are building a backend application with multiple modules in here, and we have modules, project, user, and API. Our API will be an external facing API that will host our front-end application. And then we have our user module that contains most of the security stuff. We also have a project module that contains our boundary to the database. And in this case, we'll be using this project module as a boundary to external services as well. To define a boundary, we can just think about that as something that goes outside of our JVM runtime and touches something else. The first thing we need to do to contact external services is to find a good REST client for us. In Java world and Android world especially, there are a few good options that we could use. One of them is OKHTTP that gives us the ability to define a good pipeline of settings and then make a RESTful call. Another one is an annotation based retrofit. But in our case, because we are running a backend application, we are using Spring Framework already. The only two viable options for us are more or less the REST template from Spring Framework or the newer web client that they have introduced in Spring 5. This web client will be our final choice, mostly because it will give us the reactive capabilities. So web client is a reactive RESTful client, and with that we can pipe our reactive responses from external APIs direct into our application and our application's reactive pipeline. To start off, we'll jump into our build.gradle.kts file and define the dependencies to use this web client. We have Spring Boot Starter in our project module already, and because Spring Boot Starter web flux actually contains the web client, we can just change this dependency to be web flux instead. Note that we are already using web flux in our API module, but this time we won't be exposing any API endpoints from our project module. We will be just using the web client from there. If we jump into the code level in here, we have a project service that does most of the heavy lifting in our application. And in this case, the function that we will be modifying is the save project function. The save project takes in a project entity. And as you remember, we will be populating 4 values in our project entity. The ID comes from the database, and then we have 3 other properties within this data class as well. These 3 other properties we will be taking from an external service. This external service in our case will be GitHub, and with GitHub to be the only external service that restricts our owner and name fields to be only GitHub specific owner and names. So we will be taking owner and name and creating a RESTful API call based on that. GitHub will respond with description, a list of tags for us to use as well as the license. And we will be taking these 3 fields, adding them to the entity and saving them to the database. To get started on that, we'll jump into the project service and create a private function that we will be using to fetch this data from GitHub API. This function takes in a project, and the return type in this case will still be a unit, so we'll modify that later to return a DTO entity. To set up our web client, we can call WebClient create, and takes in a base URL which we will define. We can either hard code it in like this. So if we set up our base URL to be GitHub api.github.com, that is all good. But a better way to do that is actually to make the API be a value that we get from our application properties. So if we copy this URL and jump into our application properties file. Within our application properties, we have a few different settings already, and now we will add our new API endpoint setting in there. We'll call this API endpoint.url, and we set up that to be api.github.com. Now, jumping back into our private function that we have created, we will be modifying this to actually take in a value instead. To do that, we can start using Spring annotations. Spring provides us with an annotation called value, and this annotation takes in that we can then use. Note that because we are using Kotlin language and Spring value annotation wants to use the $sign as well as the braces to define the correct string value, we need to escape $sign. So the value that we want in is API endpoint URL, and we will be binding that into a late init variable. In this case, we'll call that variable endpoint, and that is of type string. And of course, we'll move that inside our class definition, and that is nice. So now that we have our endpoint string coming in from Spring Framework, we can finally create our fetch projects function. Instead of hard coding the string value in, we can actually just use the actual endpoint value that we get from our application properties. Now that we have set up our web client, we have our first web client implementation. We can start considering what kind of API endpoints do we want to hit and what kind of data do we want to fetch from there. This will be all in next video. This video we have set up web client dependencies as well as setting up the application properties to define an endpoint for us.